This is SpaceTime Series 24, Episode 109. Coming up on SpaceTime, supervolcanoes discovered on Mars, uncovering secret mushballs in Neptune and Uranus, and 461 new outer solar system objects discovered, but still no Planet 9. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have found evidence that a region of northern Mars known as Arabia Terra experienced quite literally thousands of super eruptions, the biggest volcanic eruptions known over a 500 million year period. Some volcanoes produce eruptions so powerful they release oceans of dust and toxic gases into the air, blocking out sunlight and changing a planet's climate for decades. By studying the topography and mineral composition of a portion of the Arabia Terra region of northern Mars, scientists have found evidence for thousands of eruptions and super eruptions, many of which are the most violent volcanic explosions known. Spewing water vapor, carbon dioxide and sulfur dioxide into the air, these explosions tore through the Martian surface over a 500 million year period about 4 billion years ago. The findings are reported in the journal Geophysical Research Letters. The study's lead author, Patrick Wiley from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says each of these eruptions would have had a significant climatic impact. The released gas could have made the atmosphere thicker, or it could have blocked out the sun, making the atmosphere colder. He says that means that modelers of Martian climate will have some work to do to try and understand the impact of these supervolcanoes. After blasting the equivalent of 400 million Olympic-sized swimming pools of molten rock and gas through the surface and spreading a thick blanket of ash up to 1,000 kilometres from the eruption site, the supervolcano at the centre of the eruption collapses down into the now empty magma chamber, creating a giant hole called a caldera. Now, as we discussed in last week's SpaceTime, calderas can be dozens of kilometres across. The discovery of 7 calderas in Arabia Terra were the first signs that this region once hosted volcanoes capable of super eruptions. Yet originally, these holes were thought to be depressions left by asteroid impacts in the Martian surface billions of years ago. It wasn't until 2013 that a group of scientists first proposed that these basins were in fact volcanic calderas. See, they noticed they weren't perfectly round like most impact craters, and they had some signs signifying a collapse, such as very deep floors and benches of rock near the walls. After meeting volcanologists, Wiley and colleagues looked for evidence of ash fallout using data from NASA's Mars Reconnaissance Orbiter. The team's analysis followed up on work by other scientists who had previously suggested that the minerals on the surface of Arabia Terra appear to be volcanic in origin. Meanwhile, another research group, upon hearing that the Arabia Terra basins could be calderas, calculated where the ash from possible super eruptions in that region would have settled. Travelling downwind towards the east, it would thin out away from the centre of the volcanoes, or in this case, the calderas. The team used images from Mars Reconnaissance Orbiter to identify minerals on the surface. Looking in the walls of canyons and craters where the ash would have been carried by the wind, they identified volcanic minerals that had been turned into clays by water. They then made three-dimensional topographic maps of Arabia Terra, and by laying the mineral data over the topographical maps of the canyons and craters, the authors could see that the layers of ash were very well preserved in the mineral-rich deposits. Instead of getting jumbled by winds and water, the ash was laid in the same way it would have been were it fresh. The scientists were also able to calculate just how much material would have exploded from the volcanoes based on the volume of each caldera. And this allowed Wiley and colleagues to calculate the number of eruptions needed to produce the thickness of the ash they found. And it turns out there must have been thousands of eruptions. One remaining question is how a planet like Mars can only have one type of volcano littering a region. On Earth, volcanoes capable of super eruptions, such as for example Toba, which erupted 76,000 years ago in Sumatra, are dispersed around the globe and exist in the same areas as other types of volcanoes. Toba, for example, is just one volcano in the Ring of Fire which surrounds the Pacific. Mars too has many other types of volcanoes, including the biggest volcano in the solar system, Olympus Mons. Olympus Mons is 100 times larger in volume than Earth's largest volcano, Mauna Loa in Hawaii. Olympus Mons is a shield volcano which drained its lava down gently sloping mountainsides. And that's very different to Arabia Terra, which so far is the only evidence of explosive volcanoes on Mars. It's possible that super-eruptive volcanoes were concentrated in regions on Earth too, but have simply been eroded physically and chemically, or just as likely moved around the globe as continents shifted due to tectonic plate movements. These types of explosive volcanoes could also exist in regions of Jupiter's moon Io, and they could have been clustered, or maybe still are clustered, on Venus as well. Whatever the case may be, Arabia Terra will teach scientists something new about geological processes that help shape planets and moons. This is SpaceTime. Still to come, uncovering the secret mushballs of Uranus and Neptune. And speaking of the outer solar system, astronomers have discovered 461 new outer solar system objects, but still no Planet 9. All that and more still to come on SpaceTime. Mushballs, giant slushy hailstones made of a mixture of ammonia and water, may be responsible for an atmospheric anomaly on Neptune and Uranus that's been puzzling scientists. A new study presented by Tristan Gouliart at the Europlanet Science Congress shows that giant mushballs could be highly effective at carrying ammonia deep into the ice giant's atmospheres, hiding the gas from detection beneath opaque clouds. Recently, remote observations at infrared and radio wavelengths have shown that both Uranus and Neptune lack ammonia in their atmosphere compared to the other planetary giants, Jupiter and Saturn. And that's really surprising because they're otherwise very rich in other compounds, such as methane, found in the primordial clouds from which the planets formed. So either these two planets formed under special conditions from material that was poor in ammonia, or some ongoing process might be responsible. Gouliart from the laboratory Lagrange in Nice says NASA's Juno spacecraft has shown that Jupiter has an abundance of ammonia, but it's generally much deeper in the Jovian atmosphere than expected thanks to the formation of mushballs. He says what scientists have learned about Jupiter can also be applied to provide a plausible solution to this mystery of Uranus and Neptune. The Juno observations show that ammonia-water hailstones can rapidly form during storms. That's because of ammonia's ability to liquefy water ice crystals even at really low temperatures of around minus 90 degrees Celsius. Models indicate that these mushballs in Jupiter could grow to over a kilogram. That's much bigger than the largest hailstones here on Earth. As they plunge downwards, they transport ammonia very effectively into the deep atmosphere, where it ends up locked away beneath the cloud base. Gouliart says thermodynamic chemistry would imply that this process would be even more efficient in Uranus and Neptune. That's because the mushball seed region would extend to far greater depths. All this means is that, like Saturn and Jupiter, Neptune and Uranus probably also has lots of ammonia, just that it's hidden deep in the atmosphere of these planets, beyond the reach of present-day instruments. But to determine exactly how deep down the mushballs are carrying ammonia and water, we'll need to wait until an orbiter with instruments that can probe the atmospheres of the ice giants close up is developed. Gouliart says to fully understand these processes, scientists will need to develop a mission to map the deep atmospheric structure and better understand mixing in hydrogen atmospheres. This is SpaceTime. Still to come. The Dark Energy Survey detects 461 new outer solar system objects, but still no Planet 9. And 2 Australian satellites launched in the latest Dragon cargo ship mission to the International Space Station. All that and more still to come on SpaceTime. Since 2013, the Dark Energy Survey has been studying the properties of a mysterious force known as dark energy, which is causing the expansion of the universe to accelerate. Understanding what dark energy is important because it will determine the ultimate fate of our universe. Whether we end in a big crunch with gravity regaining control, a big freeze with the universe simply expanding forever and ever, or a big rip with dark energy becoming so powerful the universe is torn apart right down to the subatomic level. The survey has studied hundreds of millions of galaxies, supernovae, the spatial distribution of dark matter, and the large-scale cosmic web-like structure of the universe itself. It uses the 4-meter Blanco telescope at the Cerro Tololo Inter-American Observatory in Chile. Its primary objective is determining and measuring the Hubble-Lemaitre constant, the rate at which the universe is expanding out from the Big Bang. But in the process, it's also gathered up data on hundreds of outer solar system bodies known as trans-Neptunian objects, or TNOs, nearly 4,000 of which have now been identified. These are icy worlds, comets and frozen debris which are circling the Sun out beyond the orbit of Neptune. And they include both the Kuiper Belt objects, which orbit the Sun in a ring just beyond Neptune, and the more distant Oort cloud objects, which form a sphere around the solar system, extending out for a light year or more. The new discoveries bring to 777 the total number of trans-Neptunian objects detected by the Dark Energy Survey so far. But so far, the survey hasn't found any evidence of the long-sought-after Planet 9. Hints of a possible Planet 9 first came to light when astronomers noticed unusual gravitational perturbations in the orbits of 13 Kuiper Belt objects, thought to have been caused by interactions with an as-yet undiscovered massive world. This undiscovered planet will be up to 4 times the size of the Earth, with around 9 times Earth's mass, and will be on an elongated orbit around the Sun estimated to last at least 15,000 years. If it exists, this mysterious Planet 9 could be an interstellar rogue planet, simply captured by the Sun's gravitational pull from interstellar space. A lot of Oort cloud objects fit into that category. Another possibility is that it was stolen by the Sun's gravity from another star system. Again, a lot of Oort cloud objects are thought to fit into that category as well. And then there are several models of planetary migration from within our early solar system which suggest that as Jupiter and Saturn migrated out to their current orbits, their gravitational perturbations caused Neptune and Uranus to also move further outwards. In the process, they swapped orbital positions and flung a third ice giant that was there with them out into the Kuiper Belt or even beyond into interstellar space. Yet another possibility for Planet 9. This is SpaceTime. Still to come, 2 Australian satellites launched aboard the latest Dragon cargo ship mission to the International Space Station, and later in the science report, the hole in Earth's ozone layer is larger than usual this year. All that and more still to come on SpaceTime. SpaceX have launched another Dragon resupply mission to the International Space Station. Included in the manifest of the CRS-23 mission are the Australian Research Council's Koava-1 satellite, which is carrying 4 experimental payloads for the University of Sydney and Macquarie University, and Curtin University's Binar-1 spacecraft, which will test new technology designed for eventual use in the Binar Prospector spacecraft that will be flown in lunar orbit in 2025. The launch aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center in Florida had been delayed due to bad weather.
Falcon 9's in startup.
Dragon is in countdown.
Both stages are now pressurizing for launch. Range and weather should both be good to go.
Falcon 9, CRS-23, go for launch.
That was the voice of the launch director verifying we are go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Cargo Dragon takes flight. continuing a busy year of deliveries to a crew of 7 aboard the International Space Station.
Stage 1 chamber pressure is nominal.
Falcon 9 has cleared the tower and is currently headed to space. In about 15 seconds here, we're coming up on max Q. This is where the vehicle will experience the highest amount of aerodynamic pressures. Max Q. And there was the call out for max Q. We actually throttled down the Merlin engines in preparation for that event. Coming up are 5 more events in rapid succession. Main engine cutoff, stage separation, first stage flip, second engine start 1, and then the boost back burn on this first stage will begin. Main engine cutoff, also known as MECO, is where all 9 M1D engines on the Falcon 9 first stage will shut down. This is followed by stage separation, or the separation of the first and second stages. From there, the first stage will flip to prepare for re-entry and landing a few minutes later, and the Merlin vacuum engine on the second stage will ignite to boost Dragon to low Earth orbit, and that's also known as SES-1. The first stage will then begin its boost back burn. That is the first of 3 burns needed to land on our drone ship today.
Main engine cutoff.
Stage separation confirmed.
Invac ignition.
Stage 1 boost back burn startup.
Okay, those were those 5 events. Main engine cutoff, stage separation, the first stage performed a flip, second stage ignited its Merlin vacuum engine. We're in the middle of that first stage boost back burn.
Stage 1 boost back shutdown.
Contrails being produced by the first stage. And that was the call out for the successful completion of our first of 3 burns on the first stage, the 23rd commercial resupply mission to the International Space Station for NASA. This is SpaceX's 21st mission this year, and this is the cargo configuration of our Dragon spacecraft.
Acquisition of signal at Bermuda.
You might be interested to know, in order to get into space, the rocket has to do more than just go up. It actually has to go sideways really, really fast. At liftoff, gravity is pulling straight down the rocket, and as we ascend, we tilt the engines. That turns the rockets horizontally. Now, we're still going up, but we're also heading horizontally away from the launch pad in what we call a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or 17,500 miles per hour horizontally, in order to avoid being pulled back down to Earth and get into orbit. Next event for today's mission is the re-entry burn for the first stage. That's the second of 3 burns. This is where 3 of the Merlin engines will reignite, and this helps to slow down the stage as it re-enters the upper parts of the Earth's atmosphere.
Stage 1 entry burn startup.
And there is the beginning of the entry burn. 3 Merlin engines have relit and are currently slowing down the first stage.
Stage 1 entry burn shutdown.
Awesome. That is the successful completion of the second burn. We are about 60 seconds away from landing, and the vehicle is traveling about 900 miles an hour. This really puts into perspective the deceleration. In the span of less than a minute, we'll have reduced the speed from the speed of a jet all the way down to 0 as the rocket lands. And again, this is our brand new drone ship, a shortfall of gravitas. This is going to be the first time that we are making a landing attempt on it, and it's currently perched out in the Atlantic Ocean waiting for that first stage booster to return to it.
Stage 1 landing burn startup.
A single engine, the center engine, engine number 9, has relit in preparation for landing.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And that is the 90th successful landing for an orbital class rocket, and the very first for our new drone ship, a shortfall of gravitas. That is a beautiful thing to see and a great way to start off today's mission. Next event coming up is for the second stage. The Merlin vacuum engine will shut off its engine in an event called second engine cutoff, also known as SECO. And shortly after SECO, we'll be entering a coast phase and waiting for that confirmation of a good orbit.
SECO.
Nominal orbit insertion.
And we did get confirmation of both SECO, second engine cutoff, and a nominal orbital insertion. Now, the second stage has one last major task, and that is commanding separation of Dragon a couple of minutes from now. Again, this is the second flight for this particular Dragon and the first reuse of our upgraded cargo vehicle. And when this Dragon makes its way to the International Space Station, it will be joining the Crew 2 vehicle Endeavour, currently on orbit and attached to the International Space Station. It's going to be super cool to see 2 Dragons docked to the International Space Station once again. And again, for cargo, we will be delivering over 4,800 pounds of science, research, crew supplies, and vehicle hardware to the orbiting laboratory and its crew. Now, the science and research being done in microgravity on the International Space Station has benefited our lives here on Earth for decades. What's really cool is that our new Cargo Dragon vehicle is also able to act as a laboratory in the advancement of this science and research. We call this capability Extend the Lab. It allows some powered payloads to remain on Dragon for experimentation during the duration of the mission. This is especially helpful when there is limited to no space on station for additional science, and it also helps cut down the amount of time the crew has to move payloads in and out of Dragon. For CRS-23, there are 3 Extend the Lab payloads launching with the mission, and once docked, a 4th, which is currently already on the space station, will be added to Dragon. We can talk a little bit about the upgrades that have been made to Dragon. The first is solar arrays. Typically after separation, we wait for solar arrays to unfurl from Dragon. This upgraded Dragon has been redesigned, and the solar arrays has its panels built into the trunk section itself, providing power during flight and while on board the station. Another upgrade is how we dock. Before, we needed Dragon to be berth, which is where a robotic arm from the International Space Station reaches out and grabs Dragon and will attach it to the International Space Station. Now, Dragon can autonomously dock using a centerline camera and LiDAR, which is an acronym for light detection and ranging. And so this autonomous docking sequence is what Dragon will go through in the short future as it continues to make its way towards the International Space Station.
Separation confirmed.
Dragon separating from the top of the second stage.
The mission delivered almost 2.2 tons of cargo to the orbiting outpost, including 1,046 kilograms of scientific experiments, 480 kilograms of crew supplies, 338 kilograms of technical hardware, 69 kilograms of spacewalk equipment, and 24 kilograms of specialist Russian hardware. The experiments flown aboard the Dragon include equipment to research the effects of microgravity and space radiation on the growth of bone tissue, a retinal diagnostics test to capture images of the retinas of astronauts in order to monitor vision problems which space crews suffer, known as space-associated neuroocular syndrome. There's also the NanoRacks Giteye robotic arm, which is designed to support crew activities in the NanoRacks Bishop airlock. Other experiments will test how the space environment affects the performance and durability of materials and components, which are being looked at for use in future space missions. There's a new study looking at why some plants won't metabolize specific compounds under the stress of microgravity. There's also research into easier drug delivery systems to replace those cumbersome infusion pumps. And there's a bunch of experiments by groups of Girl Scouts involving plant growth and colonization and brine shrimp. Also aboard CRS-23 are 8 small CubeSat satellites which will be released into orbit from the space station. And these include the Australian Research Council Kuava-1 satellite, which is carrying 4 experimental payloads for the University of Sydney and Macquarie University. This will be released later this year on a 12-month mission to study the space environment and space weather and to test equipment which will eventually be used to search for life on planets in the Alpha Centauri star system. Meanwhile, Curtin University's 1.5 kilogram Barnard 1 satellite will test new systems designed for eventual use in the Barnard Prospector spacecraft, which will be flown into lunar orbit in 2025. Mission scientist Professor Phil Bland from Curtin University says the spacecraft will evaluate some advanced new technologies.
Tremendously exciting to finally see it go up, and it's currently on space station and will get flipped out in maybe about 3 weeks' time. It's in the space station, so it won't be launched from the Dragon capsule. It'll be launched from, they have little racks in the side of the space station, and it'll be loaded into one of those, and they kind of spring-loaded, and then it'll be blipped out of one of those.
And what will it be doing?
So basically, the main thing it'll be doing is testing out the technology that we've developed for, which is a small satellite payload, to put all of the systems for a spacecraft on a single circuit board. And that's quite a novel approach to spacecraft design. So the main thing it'll be testing is, did we get that right? Is that secure and resilient system? We're also working with some colleagues from a company called Fugro to test some of their protocols in operating spacecraft, and we've got a camera on it. But the main thing is testing out that technology of the spacecraft itself.
What circuits does a spacecraft require?
There's computer, power management, attitude determination control, you've got comms. Normally, all those would be in separate circuit boards inside spacecraft in racks. And what we've done is try to integrate everything on a single board. Now, the difference then is that you're not trying to wire things together yourself. All of that effort is done by a circuit board manufacturer in a really nice facility, kind of places where people make high-end phones and that kind of thing. So what we're doing is we're kind of leveraging that whole modern technology of making commodity electronics and using that rather than have our people in the lab trying to wire things together.
And this is all in preparation for the Binary Prospector missions. Tell me about those.
Exactly. So all of that is on a 3-year, so we're thinking of that on a 3-year timeline. And that would be a mission to the moon, 2 lunar orbiters, and it would be to help NASA look for accessible resources on the moon, particularly ice, for hydrogen and oxygen that you could use for fuel. So all of the stuff that we're doing in terms of developing our spacecraft would be kind of learning and getting it more advanced and more resilient for that mission. Along the way, we can do cute things for industry and defense and government with that platform. What we get is that as planetary scientists is we get something we can use for missions.
How long will Binary 1 remain up there?
It wouldn't be a particularly long mission for CubeSats. You wouldn't really want to plan for more than 3 months. Actually, a lot of NASA missions have a timeline that's quite short. So what we map out is what can we do in that sort of timescale and how can we deliver data that helps NASA and helps the Australian Space Agency over about a 3-month timescale. So the mission would last about that long. The cute part of it is that there's a slightly different flavor to it, which is that we would be on a really low altitude. So it would be flying very low over the lunar surface, like down to about 20 kilometers.
The Binary 1 mission will be in Earth orbit. The Binary Prospector missions will be in lunar orbit. The space station orbits at around 400 kilometers, thereabouts.
That's correct.
What's your end of mission plan for Binary 1?
Yeah, so basically, anything that goes up to about that altitude, in the end, re-enters the atmosphere after 12 to 18 months, unless it's got its own propulsion. So the space station does fairly regular burns to maintain its altitude. If you're not doing that, you'll re-enter in like 12 to 18 months. So it'll be ours will fall back into the Earth's atmosphere and burn up over that sort of time scale.
So natural orbital decay.
Yep, exactly. And then burn up like a fireball in our atmosphere.
And what about the Binary Prospector? What's the plan there?
It'll last hopefully about 3 months and maybe longer. If it's lasting longer, then we'll extend the mission. At the end of that life, what we do is what NASA has done on a couple of occasions is pick a place on the moon where it's useful to kind of see under the surface a little bit and try and target that spot when that orbit decays and see if can we excavate a little bit of material and have a little look under the surface. And so you kind of use that crash in the end to see a little bit under the surface. So we plan for that, and we use other NASA assets and the other part of Prospector to look for that.
You haven't got atmospheric drag, so the characteristics of a lunar orbital decay must be very different.
Exactly. So basically, so the reason it happens on the moon is that the moon's gravity field is no planet's gravity field is like perfectly spherical. So it's kind of like as it's orbiting, it's almost like it's on a slightly bumpy ride, and as it gets lower, the bumpiness gets more significant. So flying at the altitude we'd be flying at, it's a bit bumpy, and in the end, that takes its toll, and the thing will orbital decay, and then it'll come down to an altitude that's lunar topography. You'll start to be worried about hitting mountains and stuff.
Now, tell me about Quava.
Yeah, so Quava is a slightly bigger one, and colleagues in Sydney they've got a program there that they've been working on for several years. So theirs is more about now testing payloads than it is about testing the bus. But I think my understanding is that quite a lot of the components for the platform itself, for the spacecraft itself, are off the shelf. The team at Sydney are more interested in payloads really than they are in spacecraft. In the case of the M2 one, UNSW Canberra, those guys build the spacecraft and I think all the payloads. The main thing they've done with this last mission is show that they can actually separate two spacecraft in orbit, which is really yummy. So that's what they've demonstrated on that one.
That's Professor Phil Bland from Curtin University, and this is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The hole in Earth's ozone layer over the southern hemisphere is larger than usual this year and is already bigger than the entire Antarctic continent. The European Space Agency's Copernicus Atmospheric Monitoring Service warns that the ozone hole, which appears every year during the southern hemisphere spring, is both larger and deeper than usual. Atmospheric ozone is important because it absorbs the sun's ultraviolet radiation, which would otherwise be harmful to living cells. The Montreal Protocol, signed in 1987, led to a ban on a group of chemicals known as chlorofluorocarbons, which were used in refrigerants and spray cans and were found to destroy atmospheric ozone. However, recent studies reported in the journal Nature have shown that China has been flouting the ban, producing massive amounts of these illegal ozone-depleting chemicals for use in polyurethane insulation products. Scientists at Curtin University have identified a new, more efficient electrocatalyst to make green hydrogen out of water. Hydrogen's long been touted as a potential clean replacement for oil as an energy source. But existing production methods, such as using precious metal catalysts such as platinum in order to accelerate the reaction to break down water into hydrogen and oxygen, tend to generate far more greenhouse gases than they ultimately can eliminate. However, researchers at Curtin have found that by adding nickel and cobalt ions to cheaper, previously ineffective two-dimensional iron-sulfur nanocrystal catalysts enhances their performance, which lowers the energy required to split the water and increases the yield of hydrogen. Well, when school kids first named the Tyrannosaurus rex at the Australian Museum Fluffy, people were amused. But now new research undertaken by the Royal Veterinary College in London suggests that T-Rex may also have been able to wag its tail like a puppy. New research reported in the journal Science Advances shows that the terrible lizard king would have wagged its tail as it ran. T-Rex grew to more than 14 metres in length, 4 metres in height, and it weighed up to 8 tons. Until now, T-Rex's tails were always thought to provide simply an anchor point for the powerful leg muscles to help steering when running and to counterbalance the theropod's massive head. Anti-vaxxers are pushing a retracted study that was found to be flawed in order to support their campaign against COVID-19 vaccines. The faulty study had both poor methodology and had drastically misinterpreted the data. Yet somehow, it wrongly passed through both the editorial and peer review process, which are designed to weed out these things, and wound up being published in the journal Vaccine. The journal's failure to identify the numerous flaws in the study represents a serious problem which taints the entire peer review process, which is meant to be the gold standard for scientific research. But as other so-called peer-reviewed COVID-19 research has shown, politics is playing an ever more dominant role over the science. Worse still, Tim Mendham from Australian Skeptics says this particular piece of flawed research has provided the anti-vax movement with ammunition, be it phony ammunition, to muddy the waters and push their narrative.
There's various studies that are put up at time to time by qualified people, academics, etc., and published in recognised peer-reviewed journals that are not necessarily crash hot. Now, the whole point of the way that science, academia, and publishing of papers works is you're supposed to write a paper, it's supposed to go through independent reviewers who then say, well, that's a bit shonky, or that's good, or whatever, take it back and do a bit more on this, and they're supposed to do that. And then it goes up, and the journal, on the advice of their reviewers, publishes it, and then it's out in the community for peer review, PEER, the colleagues and people who know about such things, and supposedly the reviewers also supposed to know about such things, can then review it and say, this is interesting, or this is not interesting, or this is completely shonky. And this was a particular one that was completely shonky. This was a study that supposedly showed, and this is what was claimed in the paper, that for every 3 lives saved by vaccinations, 2 people are killed by it. And that was, people said, well, hang on, what's the basis of this belief, and how many people have you tested, and what's your thinking about it? And within days, I mean, literally, I think it was published on June 24th and retracted on July 2nd after it was pointed out there was serious methodological flaws in the research. And of course, but in the meantime, this paper, even though it was only up for a short time, was being used by anti-vaxxers as saying, here, see, this proves that the vaccines are bad for you. The trouble is it was a bad research, bad paper, should never have been published in the first place because it was just wrong. I don't know what the reviewers were doing. I don't know what the publishing editor was doing, but it made it through for a matter of, 5 days, 7 days, a week, before it was taken down. In the meantime, it had been viewed over 250,000 times in that short period and retweeted and all those sort of things. Hundreds of thousands of people have seen this paper and it's spread far and wide by anti-vaxxers. And sure as eggs, even though it was taken down in July 2, you're going to get a reference to it for months and months and months and probably years from now to this paper. And of course, it will also add the imprimatur that they were martyred, it was censored, it was taken down. It was taken down because it was wrong.
This is bringing up the ghost of the MMR vaccination, isn't it?
Yeah, well, that was the research in quotes done by Andrew Wakefield, who's a UK doctor, published a paper on the MMR vaccine and supposed unpleasant side effects of it. And I think it was Crohn's disease that there was a suggestion that there might be a link between vaccination, the MMR, the mumps, measles, rubella vaccination, and Crohn's disease. But also what popped up was autism. And this paper had about 13 co-authors. Everyone stuck their name to it. And when there was a reaction to it and pointing out, what's your research, how many people have you tested, these other authors rapidly asked for their names to be taken off the paper. But nonetheless, the paper was around for a long time until finally a journalist named Brian Deere did a lot of research on this and pointed out that Wakefield's research was wrong. It was based on a handful of people whose kids all had autism and wanted to sue the pharmaceutical companies. And basically, the solicitor who was representing these parents and Wakefield himself were going to make money out of these cases. And Wakefield was also trying to offer his own vaccine. In any case, Wakefield was shown to have done dodgy research, dodgy figures, and was struck off in the UK.
Another martyr to the cause.
This was then raised, and it still is raised, supposed links between the MMR vaccine and autism, and this was the only place where it was put forward in Wakefield's paper and his comments afterwards. And there's been thousands of studies done since of hundreds of thousands of people, and there's no link that they can find between vaccines generally, I think, and certainly the MMR vaccine and autism rates, so it's unfortunately that is the example where anti-vaxxers will pick up on anything and they're still quoting Wakefield and still quoting these results, which are wrong.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.